Glass cannot crack like concrete, and it is much more brittle than steel. In spite of the structural shortcoming of glass, its use is unavoidable since they are transparent and aesthetic and can be tailor-made in shape and color to suit various architectural purposes. However, engineers have an interesting challenge as the way it behaves as a structural material is quite different to more common materials such as steel, concrete, timber, and masonry, as it gives little warning prior to failure, with its fracture being difficult to predict and often occurring due to imperfections invisible to the naked eye. Based on manufacturing process and other properties, conventional glass panels under heat treatment for strength improvement can be classified into three groups as normal or annealed, heat strengthened, and toughened or tempered glass. As glass is a brittle material that stress cannot be redistributed and failure is assumed once crack occurs, the failure stress can only be referred as a probability of failure. Also, as a brittle material, glass is failed theoretically by tension only, and its compressive stress is extremely high. Connections for supporting glass elements include such as continuous support frame with setting blocks and silicon sealants, clamps and friction grip connections. Deflection can be a major consideration in glass design as it affects the gaskets and sealant and the supporting frame. If not properly considered, glass to metal contact may occur and dislodging of gasket takes place. Excessive deflection causes the sealant to stretch. General methods of analysis of glass structures are linear analysis, nonlinear analysis, and finite element method. Experimental strengths or their empirical relations are mandatory for accounting the probability of material strength in different manufacturing processes. Since glass is weak in tension and post-breakage strength is not utilized, linear plate theory gives conservative values. However, in case of excessive deflections, large deflection theory was used for calculating bending stresses and deflection. AKVARIET I BERGEN, Bergen Aquarium, is a facility at Nordnes in Bergen City, Norway. It was opened in 1960, and one of Europe's oldest public aquariums. The facility was built together with the Institute of Marine Research with the aim of displaying a representative selection of Norwegian marine fauna to give the public increased knowledge of the ocean's wildlife.